Welcome to a lesson with Dr. Powell. Let's take a look at how we can raise this matrix to a power, like to the sixth power, by considering its minimal polynomial. Now, its minimal polynomial, I showed in a previous video, was actually this, x minus 1 squared. Even though this is a 3 by 3, and its characteristic polynomial is a degree 3, its minimal is actually this, which is a little smaller. So, and we're going to use this to raise it to the sixth power as follows. So we have two, and so what we do is we do a generalized synthetic division process right here. Think of x to the sixth as being x to the sixth plus 0x to the fifth plus 0x to the fourth, 0x squared plus 0x, so fifth, fourth, third squared, x, and 0. Okay, then we go along here and we drop the 1, we multiply the 1 by these guys, by 2 to give you that 2, 1 by that, -1 to give you that -1. So this right here comes from multiplying this 1 to those. And then so we have 1, we drop down the 2, multiply the 2 to those guys to give you these. Then you add right here, and so you can watch the other videos that I have on generalized synthetic division to kind of see how that process goes. But notice that we end up getting 6, -5 here as our remainder. And so we can rewrite x to the sixth as 6x minus 5. And that just becomes this right here, which should be expected because this matrix right here is actually the row operation matrix for adding 1, for taking the bottom row and adding it to the middle row. Well, if you do that 6 times on the identity matrix, wouldn't you get this? So that's to be expected. Nonetheless, you notice that sometimes in the generalized synthetic division process like this, we can see a pattern. See 1, 2, 3, 4, 5, 6, and then -5. If we were to have like x to the seventh, you can imagine that this would actually be 7, -6. Anyways, you can play with that if you will, but this is just a little example of how you can use this process to raise a matrix to a high power. Thanks for watching.